Good morning, I'm Chester Henson, and I'm going to be talking about a few of the changes that we've made in traffic standards indexes. Let's see if we get scrolled up here. Okay. Okay. The first change is Index 518. It was initiated by comments received in the 2015 design on the 2015 design standards. This is Index 518 is the ground-in rumble strips, which we use on limited access facilities. Some people got into the index, and what we had done was remove the bottom portion that dealt with ground-in rumble strips for rigid pavement with rigid shoulders. Now, we didn't think it was being used too much, but somebody evidently had rigid pavement, rigid shoulders, and they went to Index 518 to see how to handle it and realized that it was removed. So we made the decision to put back the detail that was in there, but it has been modified to show what is currently in our pavement marking selection guide, to put profile thermoplastic on audible vibratory markings on concrete pavements which have rigid pavement. So we've added back a detail. Okay. So we've added back a detail to the drawing. This just gives you a blow up the detail. It's very similar to how we've done other audible vibratory markings. It gives a distance of offset from the edge of the travel way and so forth. So next change is Index 519. Remember, 519 was originally issued with the Roadway Design Bulletin 1503, which was talking about rumble striping. It was posted with it's now posted with our 2016 design standards. You notice there's some changes to it. So this original Index 519 that was posted with the Roadway Bulletin had down in the right-hand corner some 7 notes about how to deal with rumble striping. And actually, the 4 notes at the bottom of the 519 that was in the bulletin have been deleted. We've been working on some specification changes up here, and now then those specification changes allow us to delete those last 4 notes. The changes are actually, the removal is covered in specification section 710-4.1.1. That is the final surface markings portion of 710, and we've gone through there and redone that, what is included in final surface markings, to be consistent with how the district is doing it. The last note in there actually deals with the pavement, and so it was removed and covered by the specification. These are the notes that were in 71090. This is kind of just giving you a little upfront information about what the new 710 looks like. The first note, and you'll notice that when you read final surface markings, there's a whole bunch of different conditions. This one, it deals with rumble striping. It says, when permanent pavement markings are placed on newly constructed asphalt with rumble striping. So there's one in here if you don't, if you're not doing it with permanent markings, of how to deal with the final surface markings, and this one deals with the rumble striping if it's included in the contract. So the first thing it tells you of what's included in 71090 is to use 2 applications of standard paint. Now, the first note that was in those 3 or 4 things was that separate application of paint would be paid for separately as 710. So it's not paid for separately after January. It'd be included in the final surface markings. The last three notes all dealt with pavement markings. Now, some of the issues that we had with initially was we said that, okay, the contractor would install after each day's operation the permanent pavement markings and the first coat of the final striping. And then at the end of the project paving operation, those pavement markings which conflict with the grinding operations, which is 2-lane roadways, the centerline markings, would have to be removed and for the grinding operations. And then after the grinding has been completed, they have to be put back. So there was a real problem with that. Several years ago, we had some temporary markings and we weren't using them, so we took them out. So the only pavement markings that we had on our QPL were type A and type B. The type A was a temporary marking, but again, it was installed just like a permanent marking with bitumen, with a hot bitumen. It's easy. And those markers really don't lend themselves to be taken up. You can get them up with an air hammer or a hammer and a bar. But it also, even after you pull them up, there's an unsightly spot after you've removed it. So we started looking for different options on how we can solve the problem with using the permanent marker. And what we did was we're bringing back, we used to have a temporary type D marker. That marker is a lot less expensive and it's easy to remove. So we brought that type D marker back. And now 71090 addresses that class D, type D marker. So remember, the type D marker is only for centerline rumble striping when you have 2-lane roads. If you're on a multi-lane road where you're dealing with edge lines, you're not having to deal with pavement markers. So the only time you have to deal with pavement markers in rumble striping and the conflict is when you have a 2-lane and you're grinding the center line. So this really only applies to 2-lane roadways. So next change, I'll show you this. This is a picture of what the Class D RPM looks like. It is a flexible aluminum or flexible plastic marker. This one is shown as it's about 4 inches long and 2 inches high. It just flips over when traffic runs over. It has a retroreflective sheeting across the top to give it the reflectivity. So the next change is in Index 519. This was this is the new Index 519 that shows, you know, what it's going to look like on what's out there posted. It only has the 3 notes. So it just shows you what the general notes with the other 4 notes removed. The next change was in 17346. We made a couple of modifications in 346. It's the main one had to do with the contrast markings which we allow. The 2015 indexes allowed 2 types of contrast markings. One was a 6-inch wide by 10-inch black trailer. The other was an 1.5 inch black contrast on either side of the line. For consistency, when we looked at pavement markings selection guide, we decided we wanted consistency and we wanted to use one marker, one type of contrast marking. This shows the contrast marking that we decided on. It is the 6-inch wide by 10-foot black contrast trailer. We decided on this option for 2 reasons. Since most of the contrast markings are generally permanent tape, we selected this option since all the tape manufacturers offer this option. The option with the 1.5 inch on either side was spelled out with a pay item. It had its own pay item number as 9 inches wide. So when engineers specified that 9 inches, contractors no longer had the option to choose. So that option was restricted to only 2 manufacturers. So that is one of the reasons we selected the trailing contrast marker. The other one is that we felt like it provided more visibility at greater distances. The contrast markings, when you're looking at the 1.5 inch, was fine for short distances, but when you're looking at long distance, you really didn't even see the contrast. So the next one is another change that we made in 17.346 on sheet 13 and 14. 13 and 14 before were audible vibratory markings, and those markings were actually, there's two types of audible vibratory markings now. One is profile thermoplastic and the other is rumble striping. So we took sheets 13 and 14 with dealt in general with audible vibratory markings and used them to show where to use profile markings. So we just retitled a lot of it. Instead of saying audible vibratory, it just says audible profile thermoplastic. This is sheet 14, which was just a continuation of that sheet where we also made the changes. The next change is in the rumble striping details. People said, well, okay, index 17.346 shows where to put profile thermoplastic, but where is the detail in the index that shows where to put rumble striping? Now, as Gavin mentioned before, we're moving a lot of our information to designers out of the indexes and into IDSs. So if you get into the rumble striping, this shows the table of contents when you get into the design standards. And if you go down to design standard 519, you'll notice that it has an IDS 519 that goes along with it. That IDS has the drawings that show where rumble striping is supposed to begin and where it's supposed to end. So that's just a change in where the information is. The next change is in index 17.347. This index was published with a design bulletin in the last part of fiscal year 14. It shows with starting the new buffered bike lanes of how the buffered bike lanes are to be constructed at right turn lanes. Shows where the 2-4 dotted begins and where it ends. I picked one example, the urban curb and gutter section that has a dedicated right turn lane. And one of the questions we've had is changes that we've made is to where the buffered bike lane begins. Originally, with a standard 4-foot bike lane, the lane conflict area did not begin until the taper. With a 7-foot lane, we ended up with losing a lot of the area that cars need to maneuver. So the 2-4 dotted lines represent really the conflict zone where cars are trying to move into the right turn lane and where the bicyclists are either moving into the right turn lane or moving into the keyhole lane. So this is a conflict area. This detail shows where the buffered bike lane begins. And rather than it being where the taper starts, we've extended it back, and you can see we're using the extension of the curb line. If you just take that taper and extend that angle back to the buffered bike lane, that is where it begins. Now, we've had some questions as to, well, how long is that buffered bike lane or that conflict area? What is the length of it? Before, we thought it was pretty clear, 17.346, that's determined by that distance in index 17.346. This just shows 17.346 of where the solid line begins. So from the taper back to the solid line is that conflict zone. So the L1 distance is in a table over on the right-hand portion of that. It's based on the speed as to what that distance is. So you would really lay out the solid line, and the distance between the taper and that solid line is your L1 distance. Another question that we thought most people would understand, but it's consistent with the MUTCD, had to do with the RPMs and how they were installed on a buffered bike lane. Now, Index 17352 showed how the RPMs were installed for a typical 4-foot bike lane. They were not in the bike lane. You notice that they are on one side or the other to stay out of the bike lane. Now I've shown a detail here on the bottom that shows a buffered bike lane, and just now realized that something got shifted here. What we are doing is putting a, you notice the little red squares down there. Those red squares represent the RPMs. One of them will be in the outside through lane. One of the RPMs will be in between the two buffered bike lane markings, and the one on the far side will be in the right to the right of the right turn lane. I apologize for that. The next change we made is I'm using 17502 as an example. There were a lot of the structural standards that dealt with cantilever signs, span signs, 502R high mast that we went through and redid the notes to be consistent throughout the indexes. But this change I wanted to bring to your attention really had nothing to do with the notes. It has to do with the base details and how far the drill shaft is out of the ground. This is not a change. I've underlined here what the requirement is. The index shows that the shaft should stick out of the ground 2 feet above the existing terrain. Now, we're not sure why. You go out and start looking at some of these in the field, but we see in the field that they're not done correctly. What we're finding is that 2-foot minimum is not being, we're not seeing that in the field. We can only guess maybe why that is not being done. And one of the reasons that it might not is either the engineer record that establishes when these type of high mast lights or cantilever signs or any of them, the designer is required to put the top of the foundation elevation in the plans. Now, if for some reason the designer didn't do a good job of paying close attention to where that shaft was and put an elevation down there, that elevation might not be 2 feet above the existing ground. Another reason might be that it had to be shifted in the field due to utilities or some underground conflict that was not shown in the plans. Now, if that shaft gets moved in the field and during construction, the EOR or somebody should go back and reevaluate what the top of shaft foundation elevation should be. And he should revise that elevation to ensure that it's 2 feet above the natural ground. So if you would, when you're setting foundation elevations, be sure to look at that and maintain that 2-foot requirement. The next issue is in Index 17723. Now, it's not so much a revision as it is a clarification. 17723 only showed basically what might be assumed as a diagonal wire, where you only had one set of span wire assemblies attached to the steel strain pole. Now, several years ago, we changed that. We only use diagonals in very limited applications, and now we require that most intersections use a box arrangement. So we've revised 17723 to show a more typical application for the box. Now, this is kind of the detail that we have in 17723. We did not modify. 17723 has always shown the clamp details was based on the wire size. So each wire should have its own clamp based on the previous information. All we've done in 1723 is redraw it to show what it would look like in a box arrangement. So if you got a typical box arrangement, each span steel strain pole would have 4 wire clamps to attach the wire to the thing. Now, we have had some intersections where we've seen where they were retrofitting, and we've seen where I'm not sure for whether the index was not interpreted properly, but actually 2 wires were attached to the same clamp. Now, that's the way we do it on concrete strain poles, but that is not the way it should be done on steel strain poles. That is my final comment, final revision of the order this morning. So I would be glad to take any questions that you might have. So first question is, do we have a standard that allows us to use longitudinal profile thermoplastic on ramps as a safety countermeasure? UK Dreams actually use either of the audible vibratory markings for ramps. The main concern and why, where we use profile thermoplastic and where we use ground-in rumble strips is not a whole lot different. Ramps would be something where you could use them. I would say the only thing I would be careful of when you do have them on ramps is if you've got an urban interchange where the ramp gets down close to commercial areas, they do create a lot of noise. The rumble strips will actually create more noise than the profile thermoplastic. So you need to be careful which one you use, but you could actually use either one. Is the paint to be placed on top of the rumble striping still paid for under 71011? No, that is a change that we've made. If you look at the new 710 for rumble stripe, where it talks about final surface, it says it will include 2 coats of paint. That first coat of paint is what's installed by the contractor at the end of his daily paving operations. What we expect will happen after that is the contractor will do all of his painting operations and then we'll have 1 coat of paint. Now, the next operation that will happen will be the grinding. So the contractor will come in and do all his grinding. So that second application is intended to be the paint that's installed over the ground-in rumble strip. So it's now going to be paid under 71090, paid the lumps final surface markings. How will the L-shaped RPM react when impacted from the side by an automobile or by a motorcycle? Well, it's not strong enough to impact the bicycle. I mean, the motorcycle's not going to even know he runs over it. As far as a car, you could have, if you impact it from the side and the tire catches on the top part of the flip tab, it could come up. But the contractor is responsible for all temporary markers to replace them if 3 or more are missing. So I would say it wouldn't be a big concern. The contractor is just going to have to maintain them. Are we going away from grout pads? Well, it's 2 comments. The wire screen has been removed, correct. And yes, on index 17502, where we're showing high mass lights, the wire screen is shown in that detail. Grout pads are only being used for cantilever structures. So if you look at the new indexes, and actually it's in the 2015 indexes, Cantilever signs, mast arms are the only two areas where you have a cantilever structure is where we're putting back grout pads. You do not need grout pads for high mast lights, or you do not need grout pads for span signs. So we're only dealing with grout pads on structures that have a lot of counter rotation stresses. So next comment is to maintain or refurbish audible vibratory lines, remove and replace. Let me just, break down each audible vibratory line. If you put down profile thermoplastic, one of the things that we have found with the profile thermoplastic is that trucks tend to mash the profile thermoplastic down into the asphalt. So at one time we thought we would refurbish those markings with just putting a new thermoplastic line on top of it. But we've now found that if they start pushing them down, you probably need to grind them up and replace it. Now, in areas where you have profile thermoplastic that meets our new requirement for rumble striping, I would say what you would do is remove the existing profile thermoplastic and put back rumble striping. Rumble striping, the refurbishment for it would be just another coat of thermoplastic over the existing line. So it'd be a whole lot easier to refurbish. Says the drill shaft in the data tables, for example, many drill shafts are 12 feet standard length, therefore only 10 feet in the ground. I think if you look at that standard, that if the analysis calls for a 10-foot shaft, it is assuming that it's installed according to the index and only 8 feet of it needs to be in the ground. So the shaft length does include the 2-foot area that's sticking up above the ground. Next comment is profile thermoplastic or rumble stripe. Let's see. Okay, the question is asking about the spacing between the longitudinal profile thermoplastic rumble strip needs to be. That is covered by specification. Rumble strips are, the raised portion is 30 inches apart. The rumble stripes are actually 1 foot center to center, but that's on the index and in the specification.